Okay, good afternoon, everyone. So I'm Marco Mambelli. I work at Fermilab, and I'm the lead of the GlideinWMS development group. And we use Apptainer to run containers. It's a distributed workflow system. I gave a talk last year, and I'll talk about some upgrades that we made this year. So just a review, the GlideinWMS, it's a pilot-based resource provisioning tool for distributed high-throughput computing. So we provide reliable and uniform virtual clusters that the organization can use to submit, to run their jobs. We submit the Glidein, that's our base components, to heterogeneous resources. This one is testing the resources and using different tools to provide a uniform environment, including Apptainer as a container runtime. This is leveraging Condor, both to submit to the resources and then to provide the final cluster. So in short, we have the Glideins that are the tools that work on other resources. It could be cluster, clouds, or HPC system. And the factory is the component that knows how to submit the Glidein to the different resources and what they require. And the front end is the one that controls how many Glideins they're running and looks at the queue of the user, what they need, and communicates to the factory where and how many Glidein to submit. So the result is that we provide this cluster for experiments that can run simulation and analysis, splitting their scientific computation in many small parts, right? So the HPC resources also are used mainly node by node. So we do multi-node submission and support all the primitives, but then the Glideins run independently on each node, and they provide the setup and the monitoring, the communication. The MPI is run only on a single node, right, using in-memory MPI. We had recently requests from some groups to add the support also for multi-node MPI, but it's difficult with the current backend that we use. So why we use Apptainer? Because it's unprivileged, low overhead. It's very useful, find very useful that the single file images and expanded images can be used. We use nested containers, and the factory is actually also the standard in the OSG consortium. So we started using Singularity at the time in 2017. And Apptainer, it's so when an experiment and a site allowed to use Apptainer, they negotiate. So a site could require a container in order to ensure separation or avoid interfering between different jobs, and same for the VO. And the runtime for the container, for Apptainer, can be, sometimes it's installed on the sites, sometimes it's distributed via Condor in the packaging of Condor. Sometimes it's available on CMFS, that's a distributed file system that we mount whenever available. And we provide, or sometimes we can also download it from the Glidein. So we find whichever is the first and most reliable version that we can download. And we start using the runtime and then determine the image depending on the desire of the experimenter or the job. And sometimes these images are also made available either locally or via CMFS or downloaded. And then the Glidein, that's at its core, was starting everything. It's basically a shell script. Starts Apptainer and the jobs inside it. So this year we updated, had some regular maintenance, right? Update of the images beside providing the infrastructure with GlideinWMS, we also distributed some images that especially Fermilab experiments are using so that they can find everywhere an environment similar to what they have in their local clusters. We added Alma Linux 10 support. We added some images that are not Red Hat based. Specifically also for the basic test, we added a default small Alpine image so that it can be easily used for tests when other containers are not available. And so we needed also to support non-bash based containers, which require some changes because we had a little script that runs inside the container to provide additional monitoring and services that needed to be changed to run also on BusyBox or other shells. And we expanded on-demand CFS provisioning and revised the credential use, its dynamic credential and parameter generators. I will talk about this in a little bit. First, the CFS, or CERN VM file system. If you're not familiar, it's a write once, read everywhere, HTTP-based distributed file system. So it provides the duplication, multi-tier structure, and uses HTTP to transfer the file, so it can take advantage on HTTP caching to replicate everything. We use this to distribute many things. Experiment use it for their software. We distributed also CIF images in unpacked format. And we define the image. Most of the time, actually, experiments prefer to create a Docker file on GitHub to define the images. And this is then pushed through actions to Docker Hub. And we have a service that is downloading the Docker image, converting in CIF, and OSGS, this service, and publishing it on CFS. So the expanded images on CFS are very convenient since not everything needs to be downloaded, and some experiments have several gigabyte of images with, for example, different software releases for their analysis tools. And so it's very convenient to be able to have the expanded images, download only what you need, and use the HTTP caching provided by CFS to run on multiple nodes on a cluster. So a problem that we had is that some sites either didn't want or didn't have the ability to install CFS. So if VO, an experiment is counting on that, when they specify that they need it, if it's not available locally, we currently use CFS exec, it's a tool to provision it on demand whenever it's not available. There are different ways to use that. The Mode 1 CFS exec is the most complete, but some system is not supported. That one basically is mounting these file systems and creating something similar to be able to bind mount them in the environment so that they can be mounted on an arbitrary point in the file system. Mount repo and mount repo are utilities that are working also in other environment where you have less capabilities, but the problem is that since we always run the Gleidin as regular users, you cannot, you have to mount CFS on an arbitrary directory that you own. Cannot be mounted. Most of the experiments or system or user software expect CFS mounted in /CFS. And then we, on demand mounts, we also provide the VO-defined list of repositories, so experiments or sites can customize the list of repositories that they want to make sure that are present. Apptainer, once it's started in the container, allows to bind the repositories to the well-mount root directory, so that whenever we are running inside the container, all the experiments can find their CFS where they expect it. So a lot of work in GlideinWMS this year was done on the credentials. So we have different type of credentials that are used for many things. And GlideinWMS mainly it's storing, validating, and forwarding the credentials that have been provided externally. So, so most credentials are provided to the front end. So the front end and the dynamic pool are managed by the experiments, by the VO. They are cached in the factory that's managed by operators, and a lot of time it's shared. And then they are used and also cached at the sites, used to access the sites and cached there so that they can be used by the jobs when they run, or the Glidein for service for multiple jobs. So all the credentials are, which credentials are needed for the different purposes, right, is set in the factory and front-end configuration. And we have a fine temporal and spatial, not spatial, granularity, in the sense to avoid problems if one, for example, one site is compromised or so. The front end can generate specific tokens that are sent only to different sites, can sign and specialize the credential. The credentials are used for the submission to the site, to run services that are run for the experiments at the node, that we call those payload credential. Some credentials are provided by the site, for example, to allow things like monitoring or security checks that the site, extra security check that the site requires. And some credentials are used to authenticate within the virtual cluster that we are generating, so that only the desired Glidein can join the cluster. And then also the jobs can provide extra credential, for example, sometimes used for storage. The generators allow us to create credential dynamically at runtime, depending on resources and job attributes. So we use this, for example, to a factory or a front end can submit jobs to a big list of sites. And in order to allow to, so generating, a lot of time tokens are lasting only a few minutes, right, or an hour. And generating all of them for all the sites all the time would be very time consuming. So dynamically, depending on the sites used and what they need, the credentials are generated. And the rules to do that and the context are defined into the configuration. This is used also to define things depending on a mix of requirement from sites and VOs. So we also allow self-signed site tokens. Site tokens are a type of JWT that's used within OSG to run on resources. And the site tokens are generated and signed on the front end, and the front end advertise via the OAuth standard the public links to validate and verify the tokens. So any resource can add this. How this is used in Apptainer. So Apptainer, first the credentials are available for some time for services running the Glidein to access CMFS, other storages, or other services that are used by all the jobs or by specific jobs running in Apptainer. And then the dynamic generator are used sometimes also to select the container depending on the VO and site requirement. We expanded also the testing that we use, infrastructure that we use, where we run nested container. So the whole GlideinWMS system can be emulated within a Podman or Docker Compose workflow. And since we have now self-signed generated credentials, we have fully automated tests. And we expanded the use of different configuration and type of components. So to summarize, GlideinWMS is a pilot-based resource provisioner for high-throughput computing. We use Apptainer to run the resource validation and to run the jobs inside containers that they choose. We like the fact that it's privileged because we run on different resources and we almost never, only on cloud sometimes we have a root. It has low overhead and allows a nested container that we use for testing or sometimes also to run services that are available for the different user jobs. And that single file images can be and the expanded images can be used, especially the expanded one, make it very convenient, thanks to CFS. From last year, we added support for more images. We expanded the on-demand CFS provisioning that allows to access the images, the Apptainer images, also on sites that don't have CFS. And we are we improved the use of credentials that allowed extra automation and the use of credential for services within the easy specification of credential for services within the containers. Okay.
Any questions? Anybody else? It's okay, because we're actually time for the next talk, so.